Let's start by reading the question. The functions g and h are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the minimum value of the function it defines where x is greater than or equal to 0? So this maybe falls for some of you into that category of constants questions. It's literally using the word, but this part here is not that scary because a constant or coefficient just means that it's a number that appears in the equation. So a better way to ask this question that's more intuitive, I guess, would just be, does this equation have the minimum value as a number in the equation already? That's it, right? Now, there are certain equation types where we might be able to know the answer to that, right? So the one that comes to mind is if we had a quadratic equation, right, a parabola that went up and down, let's say, or actually minimum would be going this way. So those, if we had them in vertex form, would give us the minimum as constants and coefficients because the vertex is the minimum and the vertex form of a quadratic is literally telling us as constants and coefficients the vertex of that parabola. But we don't have that here. In fact, as soon as I look at these equations, my thought is immediately I'm going to Desmos because these are crazy looking equations. So if your first thought is, let me think about it. Let me think about what these equations are going to look like. There's just something seriously wrong with you. Why would you think that you're smart enough to know what these equations are going to look like? That amount of arrogance I can't understand. And I'm being a little mean here on purpose. Like, there's something wrong with you if your first thought is, let me think about it. No, let's draw a picture. Let's see what it looks like and not use brain cells unnecessarily. Desmos will just draw this for us, right? So I'll even label it, more than I need to here, but g of x, right? So g of x is equal to, and just as you're typing, be really careful because if you mistype it, that might completely change the answer. So 1.16, and that's times 1.4, and that is raised to, now watch this here. So if I go raised to, this is the a to the b, and I just type x plus 2, watch what it did. The plus 2 is not where it's supposed to be. So this is why I say, make sure that you are showing the exact same equation that they're telling you, right? So anytime I type something into Desmos, before I start scrolling around and seeing what it tells me, the first place I'm looking is not the graph. It's back to the equation I just typed, either on my scratch paper or on the screen, in the question itself, because the odds of me mistyping something are very high. And so here, I think that's why a lot of people will struggle with this question is they'll mistype and they won't realize, but we can easily fix this. So my advice is if you've got a complicated exponent, just when you have it, just start with the parentheses. That way it knows to put everything in those parentheses in the exponent. So now we're good. So 18 times 1.16 times 1.4 to the x plus 2. Now we're looking for the minimum value. So the thing most of you will recognize is like there is no kind of minimum value, right? This thing seems to kind of go down and then it stays at the same level, right? And if you understand how an exponential works, you realize that it's never getting to that value that it looks like it's at, right? It's getting closer and closer and closer, but it's never really reaching y equals 0 here. But that doesn't matter, right? Because they tell us that x has to be greater than 0. So the minimum value is going to be where this thing hits the y-axis and then to the right of that, right? So all this stuff that is lower, I don't actually care about. The minimum value in this case, because of the instructions we're being given, is the y-intercept, which is 40.9248. Is that number any of these numbers? No. Therefore, it is not a constant or coefficient in the equation. So 1 is wrong. That's what they're asking. So now let's turn it off, and then let's go to the h of x. So type the same thing. So h of x equals 18 times 1.4 to the, and again, I'm going to use those parentheses, x plus 4, close the parentheses, and the same thing, right? It's x is greater than 0, so I have to go here. You can see it goes up forever and ever after that, but we still have a y-intercept, and this y-intercept is 69.1488, but I don't see any number like that in this question, so it doesn't work. Now I have a feeling that a lot of you are going to stumble on that answer, even if you did this completely wrong. I think it's just you're gonna pick that because I don't know, just not really understanding even what they're asking. You'll kind of be like, no, there's no minimum here. It doesn't make sense. But there is more complexity to this. And I've seen them ask this question in other ways. I believe there are questions like this on, I think, at least one of the practice tests. There's maybe multiple ones in the question bank that are kind of essentially asking the exact same thing. So you just got to be aware of what they're asking, but also aware, like I said, in a kind of mean way, of your own limitations. Is these are wacky equations. You have no hope of understanding how they're going to behave and what they're going to look like by thinking about it. So don't even bother. Just go right to the calculator and see it. And then we're mostly just doing what we're told, right? Why are they saying that x has to be greater than or equal to 0? I don't know. It's just the thing they said. I don't care why they said it. It's just the rule that they gave us. So follow the rule. But it doesn't really end up mattering. It's just that's what they asked. So I don't know. If you think I'm missing something here, feel free to share it in the comments. But this is a question where, I don't know, if your first thought is not to go to Desmos and see what these things look like, I think you're going to have a lot of trouble in the SAT, because it means you're trying to think about the SAT in a way that maybe your math teacher would be proud of, but is not going to get you any points on the test. You got to be efficient. You got to know when your brain is going to require a lot of energy to process some piece of information, and avoid those situations at all costs. It's a long test. You need to keep your mental energy high. This is a situation where as soon as I see those equations, I'm like, hell no, I'm getting out of this. Let's throw it in Desmos. So learn to have that instinct. It's a powerful one.